Hi everyone, welcome back to my channel. So today I'm going to discuss chapter number 4 of geography, that is earth structure, from Panorama Publishers. So this video I'm making on the request of Dipti. Thank you Dipti if you like my videos. So this chapter is totally on the earth structure, that what is in the earth means inner structure we are going to discuss mainly. So that we know that man has constantly explored the three realms of the earth. Do you know what are the meaning of realms? Realms means area or spheres. That we have discussed in first chapter, that is earth as a planet, that there are three realms of the earth, that is lithosphere, hydrosphere, atmosphere. So what is lithosphere? So, what is lithosphere? Lithosphere is what? The land part. Okay, so like we have something like that is the earth. Okay, like we have India, like this. So, this part is our lithosphere. Okay, this part. And what is hydrosphere? Hydrosphere means the water part, like Bay of Bengal is present here at the right side of India, and left side is Arabian Sea, downside Indian Ocean. So this is a second realm, that is hydrosphere. Then is atmosphere. Atmosphere, we know the surroundings which we are living. Okay, so, although man has been able to solve the mysteries of atmosphere beyond the space to some extent, so we are able to find sort of the mysteries. Like we know that atmosphere is what? Atmosphere is an envelope of air. And second, what we know a lot about the space, about astronomy. See, we know that there are eight planets in the solar system. Ninth was Pluto, now it's not there, now it's not given. Eight planets are only there, and Jupiter is the largest, like this we know. Okay, so but what he is also able to study the depth of the oceans in detail. See, we know oceans, the depth of the oceans too, but the interior of the earth, this part, you see, this you are seeing na, figure 4.1a. Do you know this is only a probable structure, means on the basis of the study of the physical properties of the earth we have found this, but this is not the proper one. This can be wrong also. Okay, so this is not a proper one. This is, we can say, this is a probable answer, not the approximate one. Okay, but in up to now the scientists or the geologists or the all the people who are studying geography, they are taking this one only. Okay, so they are saying the change in temperature, pressure and density. Okay, the change in temperature, the pressure and density in the earth's interior with increasing depth can be estimated from the velocity of earthquake waves through the earth and by studying lavas emitted from the volcanoes. So they are telling us that how the geologist people, they were able to find this structure. First is, whenever we are going to the interior, okay, like we have a land here, whenever we are going to interior, uh per we can say, like here it's given that 1 degree Celsius temperature goes on increasing for every 32 meters. Okay, so like we are going 32 meters, 30 meters. Okay, we are going 64 meters, so 2 degrees Celsius is increasing. Means what is our scale is that 1 degree Celsius increases in 32 meter of depth. Okay, so this is what they are saying, that there is a change in temperature when we go down to the earth. Like here in summers we are having 45, 40, 35 degree temperature, and downside there is, I think, 1200 degrees Celsius of temperature present. Okay, so what is then they're saying about pressure? What I'm telling you, that if there is high pressure, there is low air pressure. Let me tell you this thing. High, if there is high temperature, like we have high temperature nowadays in North India, So if there is high temperature in North India, so there would be low air pressure, means they are inversely proportional. If the temperature is at its peak, means if the temperature is high, so what would be the condition of the air pressure? That is, it would be low, means they are inversely proportional. Okay, so means what they are saying, whenever we go down, pressure decreases. Okay, and density we know that there is a lot of density in the earth's interior. And what they can say, it can be estimated. How we understood that there is temperature decrease, pressure change, also density, also how we understood? From the velocity of earthquake waves. Do you know what is velocity? Velocity would be it's in chapter number 1, measurement and experimentation physics. Okay, 9th standard physics only. So what is velocity? Velocity is just like speed. Velocity is just like speed. Speed is a scalar quantity and velocity, it's a vector quantity. In speed, what we are taking, speed is equal to distance upon time. This thing only we are taking, speed is equal to distance upon time. This is a speed formula. But velocity is displacement upon time. Displacement and distance, what difference is there? Displacement, what we are seeing, we see the direction also. Like if velocity, okay, I'm not going to physics, you can just for now you can say that velocity is equal to speed only, just there is a bit different, so I will tell you any day. So like any earthquake waves come, there are many earthquakes, like there were earthquakes in Assam, even in North India there are a lot of earthquakes coming, in South India also. So we can, these changes like in temperature, है ना, in temperature, in pressure, in density, these changes can, we can find these changes by the velocity or by the speed of the earthquake which is coming from the earth. So do you know the earthquake, whenever there is some change in like any rock, there is some change in the interior, if like we are saying, if any small rock is broken in the earth's interior, then there is some sort of earthquake. Okay, so there are some waves which are coming, so we can estimate it by the speed of waves, earthquake waves, and by studying lava emitted from the volcano. Okay, do you know what's the structure of volcano? Like this. So here you would be discussing this in semester 2. The students who are having a semester system, they would be having this in semester 2. The students, those who are having term system, they would be having in third term. Okay, so here the lava is coming from the depth. Okay, so lava is very hot, we know lava is very hot, which is coming. Okay, so by this we can understand that there is a high temperature. Okay, if lava is hot, then high temperature, है ना, high temperature. And if high temperature is there, low pressure, simple thing. Okay, the thermal and physical state of the interior of the earth also helps in ascertaining the structure and composition of the earth. Okay, so thermal condition means we know that it's liquid in state, or the physical state like solid, liquid, gas. It, like we know that the earth, it's a bit, lava is in liquid state, and what the state, its state also tell us about the structure and the composition of the earth. So now we are going to discuss mainly 2 points, that is first temperature, then density. So temperature, we know that I told you that 1 degree Celsius, like we go 32 meters down the earth, this is the ground, and we go 32 meters down the earth. If the temperature of 46 degrees Celsius upside, so it would be after 32 kilometer, after 32 meters, sorry, after 32 meters it would be 47, means 1 degree Celsius would be increased as we go down every 32 meters. Understood this point? Just mark this point which I have marked on my book. At this rate, the temperature, the temperature at the depth of 48 kilometer would be between 1200 Celsius to 2000 degrees Celsius. So, like if we go, this is the ground again, and if we go 48 kilometer down the earth, do you know what would be the temperature? 1200 degrees Celsius to, means it can be more than that, to 2000 degrees Celsius. Very much. At 45 degrees Celsius temperature, we are dying of this summer. And what would be happening at 2000 degrees Celsius? I think a person would burn properly. Really badly it would burn. Okay. The rocks and the material cannot remain in solid state. Okay, they cannot remain in the solid state at such a high temperature. As we know, whenever there is high temperature, everything changes to liquid part. It is therefore inferred that the source of lava eruption from volcanoes is at the depth of about 48 kilometers. So from this fact we can understand that the lava which is coming from the earth's interior, that is coming from the depth of about 48 kilometers. Means lava, this is a probability only, this is not proper one, but you have to study this thing. If lava is coming from a depth of 48 kilometers, you have to understand this thing. Okay, if we assume that the temperature goes on increasing at this rate, what's the rate? 1 degree Celsius for every 32 meters. Very important part. Okay, I would be also sending the notes of this chapter. Actually, when I was in ninth, I used to make notes because at that time I there was not so much burden because that was lockdown. So nowadays we would be getting in June or in May only. Like in North India, we are getting from 15 May online classes. So you would be getting a lot of time to study. So you can make notes. I have made notes of this chapter. You can just get it print out. Okay. Whenever I would be finding some sort of other notes also, I would be sending you. Okay. The temperature at this, like if we assume that this is the rate, that is 1 degree for every 32 meters, then temperature at the center of the earth or the core of the earth, core is this part you can see in this. Okay, this is the core part. There are two cores, outer core, inner core, that we will be discussing. This is the center of earth, the core is the center of the earth. Okay, so what were we discussing, that if we take this rate, that the temperature goes on increasing 1 degree Celsius for every 32 meters, then the temperature can be calculated to be more than 4000 degrees Celsius. Means at the center, at this part, okay, this part, there can be more than or about 4000 degrees Celsius. Do you know why are we unable to find the proper structure of the earth interior? Because of this only. We are not able to live only in 45 degrees Celsius, and what would it happen at 4000 degrees Celsius? So that's why the humans, they are unable to find, or they are unable to go there, and they have to find whatever. This is the, we can say this is a probable answer only, not approximate. Like we can say this is just a guess. Okay, so this is understood. It has also been estimated by the earth scientists that the rate of the increase of temperature inside the earth undergoes an increase at the greater depth from the surface. So they are saying the same thing, that as we go down and down, there is an increase in the temperature. This thing only they are saying. Okay, so next what they are saying, that in the upper layers of the earth, these are the upper layers, you see, crust and mantle. Okay, an important source of heat, what is like in crust and mantle, there are two important sources of, not two, but in your book they are given two, is the radioactive minerals. Do you know what is radioactive? Something that emits heat, something that gives out heat, like uranium and thorium. You would be discussing this part in your chemistry, I think. Okay, so the minerals are more abundant up to a depth of about 100 kilometer below which they are formed in much lesser quantities. So do you know what they are saying? That they are saying, like we go up to 90 kilometer or 100 kilometer, I'm going to take 90 kilometer, there are a lot of minerals present which are very good for our health. But if we go below 100, if we go below 100, okay, below 100, okay, so do you know what would happen? There is a less quantity of minerals. Less quantity of minerals means below 100 kilometer there is less quantity of minerals present. So now the thermal conditions of the earth may be summarized. Now this is a summary of up to what I have explained you. This full page, first page summary is this thing, only this thing, important part. The thermal conditions of the earth may be summarized as follows: that at the depth of about 48 kilometer the temperature is about 1200 Celsius. This thing also I have told you. And the temperature at the depth of 400 kilometer is about 1500 degrees Celsius. See, this part is important. This part we done. This first point we did. But you have to take care of this part. Okay, this part what they're saying, like if we go at the depth of 400 kilometer down the earth, then there is 1500 degrees Celsius temperature, about 1500, these are not sure ones. Then the temperature at molten outer core and the inner solid core at the depth of about 5100 kilometer. So this I'm showing you, they are telling about, this is the structure. First you listen only, first I think I should first tell you the structure. This is the structure of the earth. Like we have the earth here, okay. You can make this, actually I would be sending the notes also. I would be finding some ways by which I would be able to send you, or I would be able to provide you the notes, okay. So if you want you can practice this on your rough notebook. So this is the earth, and here this is the part we are going to make. This is very small, the crust part is really very small. This is the crust part on which we are living. This is crust. And the next part is mantle. M-A-N-T-L-E. Not write M-E-N-T-A-L. That's something different, you know. And that next is outer core. This is called outer core. Okay. And this part is inner core. Okay. Understand this point? So first you have to just learn in serial order: crust, mantle, outer core, inner core. Very easy this point. Now you would be able to learn this chapter or understand this chapter much more easily. So now they are saying the temperature at molten outer core and the inner solid core, means the outer and the inner core. This also you learn that the inner core is at the depth of 5100 kilometer. 5100 kilometer is estimated to be 4300 degrees Celsius. 4300 degree. Okay. So now you would be saying that in first page of this chapter that we done, that at the center of the earth, that is the inner core, there is about 4000 degrees Celsius, है ना? Here they are saying 4300 degrees Celsius, because I'm telling you everyone that 4000 degrees Celsius, 4300 Celsius degrees Celsius. So at these both they are writing about. About means estimately, means guess. This is just a guess, this is not proper one, okay. So if you write this one, that is also correct. If you write 4000 degrees Celsius, that is also correct, okay. So if sometimes there is a test and teachers are doing something wrong, so you can just show this on your book that ma'am, here it's given 4000 degrees Celsius, or here it's given 4300 degrees Celsius, so I read. And you can say that even about word is given. This means this is not the proper one. About means it can be less also, it can be more also, okay. So now we're going to discuss the pressure. We know that the pressure, high temperature, low pressure, low temperature, high pressure, means they're inversely proportional. If something is less, so the next one is more. If something is more, then the another one is less. So the pressure exerted by the weight of the atmosphere. See, atmosphere has a weight. You know, gases have weight. That we have done many times an experiment, balloon one experiment, that gases, that's for filling up the space. But we have done in fifth and sixth that there are many experiments we did. So they are saying the pressure which is exerted by the weight of the atmosphere inside the earth has been used to determine the composition and the structure. How is pressure able to help us find the composition or understand the composition of the earth? That we are going to discuss. Mainly they are saying that we will tell you that how is pressure telling us about the structure of the earth. Okay, one atmospheric unit equals to, do you know what is atmospheric unit? ATM. Not that ATM is not that we are using for getting out the cash from any ATM one, whatever we are getting from any bank. This is a unit, ATM, that you would be using in physics, okay, in ninth standard only. So one atmospheric unit equals to a pressure of 14.7 lamb. Okay, this is that one ATM is equal to 14.7 lamb. LB means lamb, okay, per square inch. Okay, per square inch. This you have to write 1 inch. 1 inch equal to 14.7 lb per square inch. This you have to write. Don't forget to write per square inch. Your answer will be totally wrong. At this rate, at the depth of 2500 kilometers. So this is a rate. Just like we done that 1 degree Celsius is increased whenever we go 32-meter down. This is also the rate of pressure. So they can ask what is the rate of pressure, what is the rate of temperature as we go down. So at this rate, at the depth of 2500 kilometers, so if we go downside at 2500 kilometer, the pressure is about 1 million atmospheres. 1 million ATMs. 1 million ATM, atmosphere unit. And at the core of the earth, the pressure is estimated to be 3.5 million. At the core is the center. You know, I discussed with you the structure. So at the center there is 3.5 million atmospheres. This is the pressure. So this is something related to physics. So this is just the rate. If you know the rate, you would be easy to understand this part. Rate of temperature is 1 degree Celsius. Whenever we go down, it goes on increasing 32 meters. And what is for the pressure? That is 1 ATM is equal to 14.7 lamb. Okay. Then is density. The average density. Density is what? Average density means weight per unit volume. Weight over volume. Or mass over volume. This we done in 8th standard. Mass over volume. That is density. Okay, so the average density of the earth is 5.5. Okay, you have to learn this part also. You have to learn just these three theoretical things or three physics type things. I know that many of you don't like physics, even many of you don't like geography, but you have to do this. The surface layer of the continents. The surface layer of the continents composed of seal.